Hi, this is my heartbeat right now, slightly elevated. Um, Normally it's around 60, 70, slightly elevated. Um, this is running in a browser, and the heartbeat monitor is using Bluetooth. I have it here. So I can take this off, and then it should stop updating. Right. So we're gonna have some fun with Bluetooth. At least we're gonna try to have some fun with Bluetooth. So, why Bluetooth in a browser? Well, there's actually only one answer to that, and that is progressive web apps. Progressive web apps are great. You can basically build native app-like experiences. You can have offline support, you can have full screen, add to home screen, push notifications, and that works really good. Except it's mostly limited to your phone or to your desktop device. There are ways to get more information about the world around you. One big way is the network, of course. There's location APIs, sensors, you can use the camera, but mostly network. Now I have all these kinds of devices in my home, like a Sonos, which has Ethernet and Wi-Fi. I have one of these things, has Wi-Fi, and I have Philips Hue light bulbs, and it has Zigbee, but actually there is a hub that has Ethernet connection, and then talks Zigbee to the light bulbs. So all of these devices have a network connection. So I could talk to these devices. Fetch, XML HTTP request, that should work because the hub in this case runs a web server and you can talk to it. Actually, it's not that difficult. But first, these devices, they run on your local network. So you have to find the local IP address. It doesn't have just a domain name or something like that. There's an API for that. Philips provides an API. You can just request all the devices, Philips Hue devices on your network. It looks at the external IP address of your phone and then compares that to the external IP addresses of the hubs. And when they are the same, you're probably on the same local network. So once we have that IP address, we can then query the hub, can get a description.xml, check the version number if it's the proper version, and then some security. We have to call an API and then press a physical button on that hub, and then we get an API key. And we can store that for later use. And that is important because Sonos doesn't do this. So if you have a Sonos or a friend with a Sonos and you have their Wi-Fi connection, you can just walk up to their door in the middle of the night and start playing really loud, annoying music. Because it's just an open HTTP request. So we can get the lights, the color, the state, everything, and set the color, light, and state, and everything. And this works. So we create a PWA, a progressive web app, and we add some buttons for this, and we implement everything. And then we click, and we click, and we refresh, and we click, and then this doesn't work. And it should work, but it doesn't, because progressive web apps have a problem with the local network, because progressive web apps are HTTPS only, and the bridge works in HTTP. So this is a problem, and because the way certificates work and local networks work, they can't get a certificate because the device has to be on the external network to get to validate the certificate, and it isn't. So this is a problem. The network is just for accessing remote APIs. It isn't for accessing local devices. There are ways around this. Philips has a nice API for that. So you go through one of their servers. So if you turn off a light, it goes to some data center in China for whatever. And then it goes back to your own network, and then it turns off the light. And that's, yeah. This is what they say. We are currently preparing for release of this remote API, which will initially be available to limited number of partners. So it isn't really open, and currently was 2 years ago. It's very limited and it's not available yet. So far this talk has been PWA problems with local networks and not much Bluetooth, but we're going to change that. The ideal way to connect to local devices is using Bluetooth. And we're going to have fun with that. So the first thing when I mention Bluetooth is usually somebody says Bluetooth sucks. And they are probably right, but they're thinking about classic Bluetooth. That's the reason why everybody hates Bluetooth. But Bluetooth Low Energy is actually pretty cool. You can control drones and robots and other cool shit. So Bluetooth Low Energy is known as Bluetooth Smart, Bluetooth LE, BLE, Bluetooth 4, Bluetooth 5, and you have all kinds of Bluetooth devices, like light bulbs, cute little robots, drones, activity trackers, well, the heart rate monitor I just wore. But how can you access all of these devices? How can you talk to them? And then we get to the boring theoretical stuff. I'm sorry, the fun is gonna have to wait a little bit. So we have two types of devices. We have centrals and we have peripherals. The central device is where your app lives. And the peripheral, that is a device that you control. So a central device can talk to multiple peripherals, but each of these peripherals can't talk to each other. And they can only talk to one central at a time. So the drone can't talk to the light bulb. But the central can talk to the light bulb and can talk to the drone. So they can relay messages. This is just basic network topology for Bluetooth. But on top of that, there is a profile, a way of sending data, and it's called generic attribute profile. And of course, the proper, it's get and not GAP, which would be logical, but GAP was already taken. And in the profile, we have no longer central devices and peripherals, but we have a client and a server. And the app is the client that talks to the server. So your light bulbs run a server. Each of these devices have certain services, like device information service, which is a standard, and a light service, in case of a light bulb. And there are multiple services per device. A drone could have a device information service, a battery service, a flight control service. And our cute robot has device information again, battery, steering control. An activity monitor, device information, battery, heart rate. And there's even standard for heart rate. But of course, with all those cheap Chinese devices, not all things are logical, and they don't have always device information or battery, and sometimes heart rate. Well, they just invent their own standard. A little bit more expensive one, the one I just wore, does have all the standard services. Now, inside of a service are characteristics. like the device information has manufacturer, model, and so on and so on. Now, think of it like this. We have a server, services, characteristics, and values. It's kind of like an array of objects, an object, properties of that object, and values. But just complicated words. Because Bluetooth isn't really a web standard. Services and characteristics are identified by unique IDs, like 16-bit or 21/8-bit. And they look like this. This is device information. It's 180A, and the longer version. And battery, 180F. And if you have your own custom characteristic or service, you can use the longer one. The shorter ones are not recommended because they might conflict with the standard. But of course, everybody uses just the short ones. So device information we just looked at, that kind of looks like this. And that's not really readable, but it's saving bandwidth. And with Bluetooth, you have very limited bandwidth, so this is important. Each characteristics, each value, you can read, you can write, and you can notify. Notify basically means you add an event listener and you get updates whenever the value changes. And every value is an array of bytes because data types, well, they don't exist in Bluetooth land. You just have an array of bytes. So, phew. This was the boring theoretical part. Now, not yet the fun part, but we'll get there. Just let's look at how this works. I have an app here on my phone. I can inspect devices. I'm going to look at the play bulb. It has certain services, device information service, battery service, 90% battery level. And there is a custom service. And there are a whole lot of custom characteristics. And we're interested at the top one. There are 8 bytes here. What happens when we write a value to this? For example, 00FF0000. And lightbulb turns red. So, what happens if we write 0000FF00? Turns green. And what do you expect when you write 000000FF? It turns blue. So that kind of looks familiar to how we write HTML, in HTML and CSS, how we write colors. Now there's the first byte. That first byte, if we turn that on, it turns white. So there are 4 LEDs in this light bulb. One for white, one for red, one for green, one for blue. And each of these bytes turns on the LED. So this is, well, we can play with this. We can basically create any color by turning on one of these LEDs. That leads us to the next session. So this was boring facts about Bluetooth. Now, fun with Bluetooth. Well, first, WebBluetooth API. So the fun part is coming. Don't worry, don't worry. Connecting to a device. Well, you need an API for that. And there is an API for that, and it's called Navigator Bluetooth.requestDevice. And you can basically request a connection to any Bluetooth low energy device in the room. And you can specify the filter to make the selection smaller, to make sure you have the right device. For example, if I want to connect to one of those light bulbs, I can say a name prefix. or I can filter on which services are supported. And then if I just do filter on name, I do have to provide which services I'm actually going to talk to. So that's the optional services parameter. So when I call this in my browser, I get this dialog. And then I can get the device. Then I get a promise. And then I can connect to the get server of that device. Again, I get a promise. I can get the service I want to talk to. Then I get another promise and get the characteristics I want to talk to. And then I can write data. In this case, I'm going to write data, and I'm going to create a uint8 array, which is basically just an array of bytes. And I'm going to put some bytes in it. The first one is 0, and then the values for RGB. So this is actually not that difficult. Reading data, you just call read value on the characteristic, get a promise, and that promise contains a parameter, and that parameter is the data. You can get individual bytes out of that data, and we have the RGB values of the current state of the light bulb. Now, getting notified of changes, I said it was kind of like add event listener. Well, it is actually add event listener. You add an event listener to the characteristics with characteristic value changed, and you get the value in the event. Of course, you need to start notifications first, because we have very low bandwidth. We don't want to flood the network with all kinds of notifications if it isn't necessary. So once we start notifications, we get the events. So to play with this, you need to know a couple of things. WebBluetooth, well, promises and typed array, and that's all you need. Well, not all you need. You're also going to need a browser. And currently this is supported in Chrome, Opera, and Samsung Internet behind a flag. And it's actively being worked on in Servo, which is an experimental browser from Firefox, or from Mozilla. And, well, not entirely experimental, but features that are being developed in Servo are going to be moved to Firefox. So this will probably end up in Firefox too. On iOS, we have an app called WebBluetooth, which takes the Safari WebKit rendering engine and adds this API. It kind of works for demo purposes, but I wouldn't browse the web with it. So I talked about Chinese devices that are maybe a little bit wonky. To show you how bad it can be, let's take a look at some devices. This is the light bulb. I have one right over there. This is the easy one. You just write a byte, an array of bytes with the values RGB, and that's basically it. I bought another light bulb, and it's a little bit weird because now you write the values RGB, but it's somewhere mixed in the middle of that byte array, and all the other values have to be exactly this. Otherwise it won't work. So you have one byte G, green, and another 3 bytes, and then blue, and another byte, and red, and another 2 bytes. Just, it's weird, but it's not really difficult. This one is a little bit weirder, because every message has to be different, so there has to be a random number in there, and then you have to calculate a checksum to make sure it's actually a valid, well, this is, again, really weird. And the worst part of this is you can't actually read the current color. So you can only set it, but you don't know if it actually worked. You don't get any feedback. and you can't read it, so you can't check yourself either. And finally, I have this light bulb. It's from directly bought and imported from China. And writing is not that difficult, but reading is really weird. Because you first have to add an event listener to a certain characteristic. Then you have to write a very specific value to completely different characteristics. And then you get an event on the first characteristic. It's just, but at least you can get the value. So it's now time for the fun part. At least the fun part for you, because I'm really scared about this. Because this is experimental technology, just setting low expectation, just so you know. And basically everything can go wrong, and then it's the browser's fault, not mine. And at home, this all works. Yeah. But, well, on conferences, there are a lot of people with Wi-Fi. And Wi-Fi uses the same frequency as Bluetooth, so that kind of also adds interference. So, yeah, here goes. Just take a moment. All right. So we already did the first demo. On to the next one, the light bulb. So I have this light bulb. It's actually on right now. And I built this demo. I can connect to it. I'm really happy if that works the first time. Okay. Click on it. It works. Some other colors. Wow. This already went better than I expected, so that's all right. Let's put it right here. What else can we do? I have these colors right here. I can just, that also works. Well, if you compare the colors on screen and the light bulb, it's a little bit off. That's not because of my demo. My demo is perfect. That the light bulb, of course. Now, seriously, the intensity of the different LEDs in the light bulb are different from what HTML expects a color to look like. Let's try something else. Of course, that is the first failure of today. But believe me, you can animate the colors of this light bulb using CSS animations. So let's move on to the next one. I have this Lego robot here. Just gonna turn it on. And now I'm gonna very carefully try not to drive it off that table. It worked. Now, the fun part is you can actually use other devices to talk to this Lego robot. I have here a gamepad. I can use the gamepad API to actually do this too. So the gamepad talks to the browser talks to the robot. And see, I can put it right down. Driving this thing is ridiculously complicated. But I thought about that too. I'm just going to put it right here. So we can actually animate the robot too. So I have here keyframes, CSS animation, and I'm using CSS custom properties for the direction, left, right, forward, backwards. And then I can turn on the animation. And it should start following the directions. I would love to show this on the table so everybody can see it, but actually I can. It's a little bit less impressive, but I can just remove the forwards and the backwards. Right. So I'm just going to turn it off in case somebody hijacks it. And so I do have one more demo here. If you're sitting at the front row, please be careful. And if I accidentally fly into this screen, I'm really, really sorry. I have literally no experience doing this. And there's this small Lego minifig on top of it. It's just a drone. And yesterday during a practice, I almost decapitated the minifig. And one of the rotors went flying through my room. So, again, lowering expectations. So let's try this. Connected, yes. So like I said, this is experimental technology. There it goes. And I can go up. And I can go down. I can turn. Or actually, I can use this one. And up. Not into the screen, please. I'm not going to fly over the audience. That yeah, this just. All right. Land. It works. No accidents. Yay. So, the demos. Well, I'm sure you'll agree this is just fun. So now back to the boring part. So what did we do? We changed the color of lightbulb, and the URL of the demo is right here behind me. We drove a rover using the gamepad, and CS animations define a path. Again, the demo is on these URLs, and we controlled a drone from the browser, and the first one was the pulse, the heartbeat. So all these URLs will be in the slides. I'm going to publish them after the talk. Okay, a little bit more information. The physical web. Maybe you've heard of this. What does it have to do with WebBluetooth? Well, not that much, but maybe soon it will have something to do with it. Physical web is basically a Bluetooth beacon. It's really small. Battery lasts literally for years. And it sends a URL to your phone. So if you have an Android device, you can get a notification like this. There is a Bluetooth beacon, physical web beacon nearby. And if you open that URL, you immediately go to, well, this website. But you can do more with this. You can open progressive web apps. And progressive web apps can talk to Bluetooth devices. So what's coming soon is you can actually connect from your telephone automatically to the device that's sending the physical web signal. So, for example, what you could do is you have a parking meter, for example. You go near the parking meter, your phone buzzes, there is a progressive web app for this. You click on it, and it automatically connects to the parking meter. And you can pay for parking. And with web payments, for example, with one touch, you can actually pay for the amount of time you want to park. Or for soda machines, or, well, a lot of possibilities here. You could actually take this one step further with something like this. This is called a PuckJS. Again, it's really small. I have one right here. And it supports physical web. It's a physical web beacon, but it has a button and it runs JavaScript. So on this little device, there's a chip that runs a JavaScript interpreter. And it supports the WebBluetooth API. So imagine what you can do with this little button. Well, you can talk to it from your progressive web app, but that's not what I mean. You can actually talk to other devices. So, for example, if this works, it doesn't work. It's probably, if I remember correctly, because this device is still connected to my computer. So, yeah. All right, let's try again. So this is a demo I literally thought up yesterday afternoon. it's not gonna work. What I had in mind is you click on this button and it changes to a random color. You hold the button for a long time, it turns off. But what you can actually do is hold the button not that long, but longer than just a short press, and it turns into knob mode. And you can turn the Bluetooth beacon to change the color, because it has an magnetometer, and it actually can change, detect the changes in the gravitational field. So if you turn it, well, it comes from a different axis. So you can use that to change the color of the light bulb. And if you want a demo later on with a little bit less pressure, feel free to come up to me and I'll try it again. So writing for this is really simple. You have a web app, basically, and that uses WebBluetooth to talk to the Puck, and you can literally write JavaScript with it. Just this is the code that runs on this Puck. That didn't work, but all right. With that, I wanna thank you for coming, and I hope you had a little bit of fun. I just want to say, if there are any questions, I'm happy to take them. Or otherwise, if you want another demo, just come up to me afterwards and I'll try again for you.
So basically, to how many devices can you connect at once? Like, is there some kind of limitation that you could only connect to 10 light bulbs or whatever?
I haven't found a limitation yet. I'm sure there is, but I don't have enough Bluetooth devices to actually reach that limit. So I'm not sure.
If you have a slow network or Bluetooth or something, have you found that interacting with the devices can have a bit of delay? So, for instance, with the drone, do you find it nice and responsive, or is it a lot of kind of testing to get kind of real-time interactions with it?
It works pretty well real time. Of course, the more traffic on the network, just the more more Bluetooth devices and more Wi-Fi devices there are around you, it's gonna affect performance, sure. But the demo that didn't work, I can run CSS animations with colors just on this, and it works pretty much real time. Just gonna try one more time. Now it works. So it pretty much changes the color exactly like the light bulb. So there is a little bit of a delay, but weirdly enough, this one is a little bit ahead of that one. But that has to do with the different intensities of the color LEDs.
Why are you using CSS animations for this? Is it just a syntax and you're parsing those?
Why? Because it's fun. There's literally no practical aspect to this, but I thought it was neat. How this works is actually I change the value of the light bulb on the screen with the CSS animation. And then I regularly pull that color, get that color from the light bulb and send that to the light bulb. So this is actually really simple. The whole animation that comes free with the browser. What I'm actually trying of working on, that's kind of similar to this, this rover, this also uses CSS animations, but I could actually draw a path using SVG and then drive the rover along that path. And well, I'm not using the rover for that. I have another Bluetooth robot that actually has a little pen. And I can put that pen on the ground, just a roll of wallpaper, and I can actually write an SVG path on that wallpaper. It's not working quite yet, so I didn't bring it with me. But just using different technologies to make some fun.
So I have two questions. First, how far is the workable distance of this Bluetooth connection, especially when I'm thinking of the drone? And is there any exclusivity to the connection, or could anyone else in the room also connect while you're connected and hijack your commands?
Good that you... I'm just going to turn this off. I actually was at a conference not too long ago, and somebody also demoed this exact same drone, and that one got actually hijacked during the demo on stage. So yes, you can hijack this, because there is basically no security who can connect to one of these devices. So if you want to go to, let's say, bricks.blue/tooth, the first one that uses Chrome for Android, of course, that connects to this one, has control over it. It's turned on, so go ahead and try. Any other questions? Oh, sorry, the range of the thing. Usually about 10 meters, 15 meters. With the new Bluetooth 5 standard, it's going to be extended to 25, 30 meters. So the range is limited, but it's for interacting with devices that are near you, not on your... It works. So, any more questions?
Hi. How do you determine how to connect to the devices or how to talk to the devices? Are there any documentations, or do you just try?
There is documentation for Bluetooth itself. There's documentation for the WebBluetooth standard. There's documentation for the standard services and characteristics. So there it goes. So there's documentation for that. How the light bulbs work, that is just sniffing the data on the network, or what I did is just downloading the APK, disassembling it, and looking at the source code. And then, well, some of these apps are built in China, and they look pretty crappy. They don't just look crappy. If you look at the source code, it's just a mess. And, well, but at least you can figure out how such a thing works. And ooh. And actually for this one, there is pretty good documentation. And for that one, it's using a specialized, sorry. It uses an S-brick. This is not made by Lego itself. Getting hit by my own drone, or by my own rover. I'm just gonna turn it off, but so there's actually, for some of these products, there are actually good documentation. So with that, I think I'm all out of time. I'm just gonna quickly pack up some things. If you want to see more demos, I'm right outside after this talk, so don't be scared. Please come up to me.